So let's do one final visual look at the spread of information or the distribution of responses relative to the mean. So earlier we went into analyze descriptive statistics and frequencies. We clicked on total delay reason, moved it to our variable box, clicked on statistics, and we selected mean, median, mode, skewness, kurtosis, minimum, maximum, range, variance, and standard deviation. So lots of different techniques here. I want you to choose charts, and I would like you to choose a histogram. And on that histogram, we'll show the normal curve. And then press continue. So let's have a look now at a complete normality test. So here we go. So we have our statistics box to show that we had 120 valid responses. Our mean, median, and mode are all quite similar to one another, ranging between about 17 and 18. So that's a good sign. We can confirm that our data is normal because our skewness and kurtosis values are between negative 0.5 and positive 0.5. We can confirm that our range is 20 because the lowest response was 6 and the highest was 26. And from that, we can look at the variance and the standard deviation. So here's a great indication that the variance is an unstandardized value. In other words, it doesn't tell you very much on its own. It's a number that represents just the differences, the sum of the differences between each response and the mean squared and divided by the population size. But that output, that number you get, 13.7, isn't valuable in the sense that it doesn't tell you much about the spread of those responses. When you square root that variance, you end up with a standard deviation value of 3.70304. And if you scroll down to our histogram, we can confirm here standard deviation of 3.7, essentially saying that if you take the mean, the arithmetic mean of our data, and you went 3.7 this way, and you went 3.7 this way, the majority of our responses would fit within that range. So it identifies what is the spread of our responses. If we had fewer responses in these portions of our curve, so on the right-hand side, this little part, and on the left-hand side, this little part, and we had higher bars here in the middle, we would have a smaller standard deviation, meaning that we would have fewer responses towards the edges of our histogram. Inversely, if we had smaller rectangles and bars in the middle and higher ones on the sides, we would conclude that we would have a high standard deviation because there'd be a wider range of means across our data set.